in the continuation of the yesterday's, what we um, left, but still we will be proceeding um, by re-uploading the dataset and starting how we will be examining the dataset. So today we will be conducting a exploratory data analytics, including the visualization part. And as I explained yesterday in detail, the role of visualization, data visualization, and storytelling. And as a data analyst and advanced data analyst skills, data visualization is one of the key parts. And this is how you will transfer and convey the message to the audience. And how it will be done, it will be only done through visualization. And within the data analytics context, exploratory data analytics is one of those um, important aspects that we have to start with. And I will explain to this step by step the like analyzing a data set and including the visualizations. Yesterday we did some imports. So we imported the relevant um, libraries within the Python. We imported the dataset. So I explained to you how we imported the dataset. Then a step two, which is the data exploration. Data exploration is how our dataset looks like, for example. We explored just only 10, for example, rows of the dataset. And we saw how the dataset looks like. For example, we have company, we have valuation of that company. We have a date joined. It means the company which joined the unicorn status. We have the industry in which company has been established. We have city where the company has been established, the country where the company has been established, continent relevantly, year founded the company, funding, how much funding currently the company has, and select investors. Who are the investors within this company? So this is the data set of the companies. Now, in order to explore properly the data set, what we have done, we just started with the um, shape. The shape says that we have 1074 rows, data points, and 10 columns. So we said, okay, in order to understand uh, the duplicates, let's drop the duplicates. So we did, and we used the drop duplicates, and then we dropped the duplicates. Then we also used info.info method for the data set. Here we see that we have some missing values. See, in city we have some missing values, um, and uh, where else select investors, we have some missing values. So these are some missing values that we have for these two columns. And look at this, for example, year founded, it's an integer. For example, funding, which should be money, yeah. So it should be integer or float. It is now object string. So this is one of the problems right now from the data point of view. Valuation is should be numbers, yeah. Look at this, it should be numbers, yeah. But this is object, which is string, which is not date joint. It's just object. So in detail, these are the date the D types of those uh, types of data within the data set. So these are different types of the data set. One more thing that I want to add here, for example, we have to also examine the missing values. So properly understand the missing values. However, from info method, we can understand the missing values. But here, for example, if we say missing values, so we just automatically companies is null. Null is the method which we just understand the missing value, and it gives us the missing value. In sum, it gives us actually the sum of all missing values within the data set. So in city, we have 16 missing values. In this column, in here, we have one missing value. However, from info method, it's also known, see, but you have to make some calculations. You have 1074, then you have to extract this much and then see, okay, one missing value. And here, a bit it's difficult now how to calculate, yeah? So you have to extract um, 1058 from 1074 and understand how much missing values there. So this is how you can deal with the missing values. Um, we did some sorting here. We also mentioned that, okay, we can do some sorting here. We sorted the values by the companies, the data set by year founded. And after that, we also did some group-wise value counts, yeah, how, where the company types stand. But before going to this step, I'll add another step, for example. Now, step one, step two, we had explored the data, yeah. So we explored the data. And let's add another step, which is step three. And this step three should be let's handle the missing values, because it's important. If you don't handle the missing values, then for you it will be difficult to calculate the describe method. Why handling the missing value is important? Just I will show you a demo here. If you type companies that describe and you enter, it should give you descriptive statistics, yeah? And it's not giving you anything here. You know why? Year founded has been described method is a method that it gives you the descriptive statistics of all numerical values within a data set. And this is not working right now. You have only year founded, which there is no need for that, yeah? So count as minimum year 1919 and maximum year 2021, and that's it, yeah? So while we have other numerical values as well, we have valuation of company, we have funding of within that company. See, these are two numerical columns, but still we don't have anything there. And why it's not appearing here? Because uh, we have to change the clean the data and also understand, handle all those missing values and clean the data properly, change the data types, then it will show you here. And this is why one more step is required here, that first of all, we have to understand the missing values. So let's see, for example, um, if we say companies uh, dot funding, yeah, and one more method, value counts, for example. Sorry, this is value counts. And still it's not appearing because you have to put it like this. Companies. So if you put just value count C, we have unknown here, different values. Yeah, here we have 539 different values within the funding column here. And we have unknown as well. So we have different types of values within this funding column as well. So if there is no column, if there is nothing, for example, if um, there is a missing value, we want that this missing value will be equal to companies, companies, funding, And do you remember method Filna? If you remember method Filna, that's the method that we are applying here, for example. Filna means if there are any uh, non-values within this column, so just fill it with what? With this. So 0 billion. So this is how we want to fill all those missing values. We just say, okay, that's 0. In the industry column, yeah, we have in the industry columns again we have some uh, missing values in the industry column. We can just put it like this: that industry filna, and if it is missing value, instead of missing value, you cannot put industry 0. Yeah, what does it mean? Does it mean anything? You should just put the industry. If there is a missing value, see, select within the industry if we have industry, and there is a non-value existing. So fill that missing value with unknown. It means that that's unknown. This is how you can fill either with 0 or either with unknown. Unknown is also a type of category. You understand? So that's also a type of category. For example, we have um, other column which is called, for example, select investors. Yeah, so this select investors. Select investors, we can do the same thing that companies select investors and Filna the same. If there is nothing there, so you can just fill it with the unknown. So this is how you can deal with the missing values within the within a data set. So let's run this one as well, and let's run this one as well, and then uh, let's run something else that uh, companies dot uh, is null.
Sir, we forgot the city.
Exactly. The cities, we're still having cities here, and we can just put that as well. Uh, companies, uh, city, it will be companies, city, filla, unknown. So cities also cannot fill the city with something, yeah? Now see, run the data set. See, there is nothing, no missing value. So this was step 3, how you can handle the missing values. Now we will be adding one more thing. Um, uh, Step 4, for example, um, they are calling it data wrangling, but also you can call it data cleaning. So let's call it data cleaning, make it easy. So for the data cleaning process, what does it mean? It means that, for example, look, we have funding amounts, yeah? One is in billion, one is in million. See? So you cannot run any mathematical uh, operation on such a column where one thing is in million, another thing is in billion, and these are also not numbers. They are objects. It means they are strings. So Python will not understand these funding these numbers as a number, as an arithmetic calculation will not be run on them. They will be used as a text. Look at this. Same thing, for example, here. You should understand how it works or not working. This is how we have to convert these values. So from the valuation in this, and also in the year funding, we have to convert all of them into billions, to a numerical billions. So this is how we will do that. Instead of doing all these things, we can just here I will explain to I will not proceed it very straightforward, but I will make another thing for you here, that it will also refresh your Python memory of functions, because on functions we didn't work properly, and we didn't work too much on functions, and you don't know how you will apply a function. So in order to clean the data, so I need something, a function to run on all these rows, and whenever there is a million, it should just convert that million into billions. How to convert million into billions? So if you divide the million, if you divide the billion into millions, so then you will have uh, uh, by thousand, then you will have the billion. This is how it will work. So from mathematical point of view, now y- whenever something is in million, you will just automatically divide it by thousand, and it will be converted to billion. And when it's converted to billion, so then just you will just put a um, number to it, and that's it. So this is how it will work. Now, to define this function and then run this function on all rows of this data set, you have to first define this function. How you're going to define a function? We will be using def. Yeah. So just give a name for this function. What will be the name of this function? Um, Cleaning data function. Yeah. This function will take a value. What will be the value of this function? The value of this function will be the row in each column. So all one row will be one value for it. Another row will be another row for it. So this is how the function in uh, this is the name of function, and this is the parameter of the function, if you remember. Now coming, we should define some conditions for our function. Yeah? If there is a very specific method called isInstance. IsInstance means that if this instance, each of them or instance, this is an instance, another instance. If it is instance, if this is an instance, and there is from this value, and this is a string, because we have right now a string, if you remember. We don't have numbers, yeah? We have a string. So within this value in a string that we have, this is one condition, yeah? If it is, then if it is B, see, if it is B, look at this. If it is B, for example, yeah? If it is B in value, this is our value, yeah? This is the value. This is the value. If there is B in the value, what to do with that? Return what? Return float value dot replace of B into just blank, and then replace it with what? With dollar sign. Where is it? With dollar sign, and then blank. If not, elif if not. It means if it is M in value, what to do? Return float again. Change the value to float. Replace it. Replace the m, and then make some calculations. Again, you will have dollar, then not divided, but stop. You have to divide. And then if there is nothing in the value, just return 0. You will understand this function when you are applying it on the data set. Otherwise, you will not understand it properly. And you will just understand how the functions, you can define these functions. And in Python, you will need it. You can do it in other ways as well, very simple ways. But intentionally, I am using the very difficult way for you, because if you just understand it, at least how it will work, next time it will be for you very easy. So on this companies, on this valuation, now we will be applying this function. Very simple. On each of them, we will be applying what? Applying cleaning data function.
Sir, you misspelled return and also companies in number 8.
Now let's check the valuation column. Yeah. So we have companies, then the valuation column, just valuation column. So it tells all the numbers, all the valuation, all whatever is within the valuation. It turns it into the numbers, into the float numbers. It removed the B, M, all these things, and then it divided all the M millions into the billions. So let's now apply the funding as well. So on the funding as well, the funding column as well, we have to apply the uh, uh, this. Oh, we didn't run this one. Now we will run this again. I think we ran it twice, yeah? I think we ran it twice. Whenever you're running too much, so it will replace everything, and all the time it will divide it by thousand, by thousand, by thousand, so nothing will remain, I think. See, this is now working. Now, valuation is 1 billion, 1 billion, 1 billion, 2 billion, 3 billion, 0.118 billion. This was all in millions. You remember? So all the numbers now have been changed to billions. See? We have 0.118 billion. Now we have 1 billion valuation. All these numbers have been changed to billion. These are all have been changed to billion. MB, those things have been removed. And now the very important thing, if you check the company.info, look at this. This is uh, valuation. This is float. Funding. This is float. See the good thing about what we have done. Uh, this is one of the type what we have done with the data cleaning. Yeah. One more thing in the data cleaning, which is important, also the type of data is very important. Previously we did this, but right now let's try it again. This date joint date that we have changed it to, to this one. See, this is very important. Instead of doing this here, which we have done yesterday, put it here, for example. This is part of data cleaning. Assigning proper uh, now date joint now became date time format. So this changing to the proper appropriate format is also uh, part of our data cleaning. Now, one more thing that in data cleaning that is there, that's called data validation. What is data validation actually? So I will not go deep into this because this is our first lesson in regard to the exploratory data analytics. But still, for data validation, you have to understand different types of data. For example, if data is valid or not. Okay, right now we don't have any missing values. See, we don't have any missing values here. But we have to also examine whenever there are very important data sets. We have to examine if if the data put in a column is valid or not valid. That's also playing a key role. You know why? Because, for example, uh, just assuming, for example, if we have a funding column, yeah, assume that if we have, mm, oh, this is text, sorry. Just put it, uh, companies dot funding column, and let's describe this. So we have, this is the descriptive statistics of this funding column. The minimum value within this column is 0, which is logical. The maximum value is 14 billion. Okay, that's also logical, for example. But look at this. All 75% of the whole column is around 0.6 billion. See? And the maximum number there is what? 14 billion. So it gives us an understanding. What type of understanding this descriptive statistics? Who can tell me?
Teachers tell us that lots of our data is not valid.
No, data is valid. It says that 75% of data is 0.6 billion, which is valid. But there is also maximum within this data set. It is 14 billion. It is called that there is an outlier existing. Outlier is a type of look at this. Yesterday, this is outlier. See, for example, it's a data point which is not um, which is not existing in a range in an proper range of this specific data set. All the range, see, it's coming from 0 to 0.6 billion, yeah? Majority of these ones. But only one of them, but the maximum point is, for example, 14 billion. So a company has been established, funded with a 14 billion dollars, yeah? So it means what? What is there? What is the point there? That's why it is actually included in the unicorn data set, yeah? Because it is already a unicorn company. So unicorn, you know that when company is funded, then it turned into 1 billion, yeah, over a period of time. But do you know, for example, a company has been established and it already established with $14 billion from the starting its funding year. So this is how you will uh, 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 um, go deeper into what is actually within the data. For example, just examine another column. That's valuation column. Valuation column. Look, the minimum within the valuation is 1 billion. It should be 1 billion. It cannot be zero, because if it is the valuation is zero, then it should not be included in this data set. Our data set valuation is that all the companies should be 1 billion or more than 1 billion. Then it should be included in this data set. Okay, so the minimum in valuation should all the time will be 1, and the maximum it's 180. So look, um, 75% of the data is in 3, but there is a huge gap between 3 and $180 billion, the valuation of a company. It is possible, but you know, sometimes you have to define the validity boundaries of your data set. What does it mean? The validity boundary of data set. Do you want to work with such numbers, huge numbers? For example, 75% of your data is actually between 1 and 3. And there is a data set, for example, a data number of 180. Do you want to keep it? Maybe that's a valid point from reality point of view, but from your analytics point of view, do you want to keep such an outlier within your data set or not? So keeping the outlier and not the outlier, that's a decision the data analyst should all the time take it and understand it properly. One more thing, you have to understand how much numbers, for example, how much data points are actually exceeding that specific number, for example, or exceeding that specific volume. So this is also the data validation boundaries that you have to understand. One more thing in data validation I just wanted to mention to you. For example, the year founded, yeah? This you cannot use the date, you have to use it like this. Look at this. Minimum year 1990, yeah? In maximum year 2021. So 25% of whole data is below 2011. So it means below 2011 date, only 25% of the data is there. And remaining 75% of the data is above 2011. 2019 is how? 2019, how many companies you would have that have been established in 1919, for example? Almost century ago, yeah? So do you want to keep that? It fits into your data or not, into your analytics or not? These are the questions all the time that you have to keep whenever you are validating the data. We will be proceeding with the data validation techniques later on in our other modules, for example, when you're doing some feature engineering, but still, this is how I can give you an idea how you will understand the data validation and what I mean by data validation. This is from structure point of view, but another thing is from context point of view. Another data validation is from structure point of view. For example, you have to validate that no values in our valuation column should be below 0, below 1. Because if a number is below 1, in our valuation column that then below $1 billion, that it means that that company is not reached the status of unicorn. If it is not reached the status of unicorn, it should not be included in this data set. Automatically, it is not a valid data point. Got it? The point. This is also type of validation. Or, for example, another thing, you have a number in column year founded, like negative minus 2012. Minus 2012 is a valid number. Python understands it as a number. It says that it is not a missing value. That's it. But do you think year founded, do we have any minus negative years numbers? No, that's then not valid number. You got how the validation from context point of view should be linked, understood, and how the validation of data from structure point of view. So this is how I want to give you an idea how we will do that. I hope you got it, yeah?
Yeah.
And that's good. So validation, data cleaning, and data validation. These are important aspects. But in data cleaning, we are just right now what we have done. We filled the missing values and we changed the data types. But two more things are remained in this exercise. The validation to validate all the data, that's one of the things. And then filling the missing values not only with zero or with unknown, filling it with something else. So we will become, that's called data imputation strategies. So data imputation strategy is totally different topic. We will be discussing that as well separately, but you will understand how it will happen. Now we have step 5, and step 5, let's examine some statistics here. Statistics. If again, that's right. So how to examine some statistics? Now we have some column, yeah. So what we had, for example, companies, and if you use the describe method, this will give you the statistics of the data set, all numerical values. See, now we have valuation. Previously, valuation was not appearing. Date joint was not appearing. See, now you change the date joint. Now date joint become what? Become a proper column. Year founded, for example. It was only appearing previously year founded. Now it appears, for example, funding. This is also appearing funding values. So look at the described value, as I mentioned previously to you. I already described to you this is the statistic. This is the mean value. Average of values within the valuation of companies are $3.45 billion. So on average, companies have been valued 3.45. Minimum valuation is 1 billion, which is a valid value. Yeah. So this column is already validated and it's valid. The maximum company which has been valid is $180 billion. Standard deviation, as I explained to you previously, it's 8.5 billion from the mean, the square root of that variance. We will be coming to variance and what's standard deviation in statistics model.
Excuse me, is it billion or million? So
Billion.
because you divided by 1,000.
Billion. If I'm divided by 1,000, then it become billion, yeah? I divided millions by 1,000 to become billion. Now date joint. So this is the column date joint. So average of all dates is around 2020. We will be coming to that why. So it's happening in that way. Year founded, for example, the minimum year founded is 1990. See, this is the minimum year that the lowest year that companies have been founded, and the maximum year which has been founded is 2021. And the date joined when they joined unicorn status, it is 2022. See, that's a valid thing. So now funding, for example, the average companies which has been funded with the capital, it was 0.5 billion. Minimum capital in a company which they founded was zero, which is also possible. With zero capital, you can fund start a company, for at least establish the company. Maximum is 14, for example. Standard deviation is 0.8. So this is all the descriptive statistics of the numerical column. This is how, for example, you can understand the statistics within the columns. For us, very important here is, for example, the valuation column and the funding column. In order to describe that, to take those specific columns, then you can just put the name of the columns there and call the describe method on it. So this is another thing which gives you an overview, and also why we are doing this step 5 on statistics, because it also gives us understanding of outliers, as understanding of data validation, as I explained already. Now there is another step 6 that we can visualize exploration. Yeah. So let's do some visualizations. And these visualizations, for example, let's, for example, say, let's start it from valuation and funding analysis. Yeah. Let's analyze the valuation and funding first. You will see what's there. So in order to analyze the funding in valuation, a specific column in order to analyze that, what we can do, we can just, yesterday I mentioned to you that we can just use SNS, 𝗔𝗱𝘃𝘃, and the 𝗔𝗱𝘃 we can use histogram, hist plot, and from the data we should put to them which data we are using and what will be our X column. You will be seeing that our X column will be valuation. The title for this valuation will be the valuation distribution in billion dollars. Yeah. The X there should be all the time X labeled. This is the standard practice of data visualization. This is a histogram of valuation distribution in billion dollars. See, this is from $0 billion to 175, 180. See, this is the valuation column from 1 to 180. So this is the column. Majority of companies have been valued at 1. Yeah, but still, this distribution shows that we have till $175, $75 billion values, which happens there. But what this distribution column, or histogram tell us? It tells us that almost all of the companies are valued between 1 and $25 billion. See, This is also the same thing, between $1 to $3 billion. So they are saying $3 billion, but still there are companies to $25 billion. This is how the distribution of this valuation columns means. Now coming in order to get proper understanding of these data sets, we have to define the strategy. What is the strategy? The strategy is, are we keeping the outliers or not? If you keep the outliers, then all these things which you're currently seeing, it will be appearing to you like this. So it will all the time disturb you. What I'm saying disturbing you, it means that all the time you have to deal with the value of 180, which is only one data point. So now, before going that, let's in data cleaning stage, for example, in data cleaning stage, let's do something else. Let's remove the outliers. Now, how to remove the outliers? In order to remove the outliers, the similar we have to define a function and then apply that function. You know what is outlier? Outlier is a type of, as I mentioned to you previously in one of our. I hope the box plot is here in a previous lecture. So this is our box plot. See, this is the box plot. This is the minimum value. This is the maximum value. This is the mean median. This is the 75%. IQR means the interquartile range. Interquartile range means that the quartile 1 of the data, which is 25% of the data, and quartile 3 of the data, which is 75% of the data. See, this is 0%, this is 25% of the data. Then this is 50% of the data, and this is then 75% of the data. So the 50% of the data, and this is 75% of the data. So from the 75% of the data, if you're removing 25% of the data, this is called interquartile range. How to remove the outliers? Some people say, okay, 1.5 times of this lower bound and 1.5 time. It means I have the maximum value. This is the bound, for example, and this is another bound. 1.5 means 1.5 of this bound. If above a value is, it's valid for me. And 1.5 of this below, if there is a value, it's valid for me. Otherwise, I want to drop all other values. So I don't want to deal with those values because those values are maybe good, valid points, but they are not part of my analytics. This is called interquartile range and dealing with the outliers. So you see this previous time, this is outlier. See, all the data are here. This is outlier. See, this is outlier. We demonstrated this. So, and also in box plots, if I think there was a box plot that we demonstrated the these are the quartiles, yeah. So in the box plot, so it was in yesterday's. These are outliers. See, so let's remove these outliers in order to have proper visualizations. In order to remove the outliers, we can define a function. So define remove outliers. For the remove outliers, we can have our data set, and then we have to define a column. So which column we want to define? Yeah. So for column 1, our data set, it will be the quantile for example, 25% of it. Quarter 3 will be quantile 75% of it. IQR will be Q3 minus Q1. Then we have to define the lower bound. The lower bound will be the quartile 1 minus 1.5 of the IQR. So this is how you first have to calculate the IQR, then calculate the lower bound, then the upper bound. So this is how you can define the lower bound and upper bound in this function. And what should be returned? The return statement will be the div column, will be the div column if it is larger and equal to lower bound. So only columns within this data set if it is equal to lower bound or larger than lower bound, then you can keep it. And this is end statement. Div column, a data set, a column within that data set, which should be lower or equal to upper bound. Upper bound is the 1.5 of IQR. If columns are in this range, so just keep it. Otherwise, just remove. Now we can say, okay, companies, for example, we can call this remove outliers function. Then we can say this data set companies, and then we call this on which column? On valuation. So companies, this data set of companies, it will remove, we will apply this remove outlier function on this data set. See, we have to define a div data set. We define the data set, which column? On valuation column. And that's it. Similarly, we can say, okay, company remove outliers on funding column as well. Yeah, so we can do that on funding column as well. And on year founded, you can do the same thing. Yeah, so do you want to remove the 1919? Let's do that as well. So year founded as well. Now let's see what happens. And then you can just call companies dot describe. Now in valuation, you have the minimum 1, the maximum 6. See, not 180. And funding, the minimum 0.0 and the maximum 1 billion. So not 14 billion, which was the outlier there. See, this is how you can just change the outliers. Now see, when you change the outliers and then you are removing unnecessary columns, then all your visualizations becoming normal. See, this is how your very good visualization will look like. So I hope everything here is understandable and properly described. This is how we can use for example, the histogram of valuation. Now, from this histogram, you can understand that the majority of funds are starting from 1 billion, and more than 400 companies have been valued 1 billion. Only a small number of companies have been valued at 6 billion. See, this is a good understanding of how valuation works. Now let's work on for example, is plot of what? Of for example, of companies from funding. Yeah. Let's divide the bins into 30, for example, and make some other calculations what is 𝗗𝗃, for example. I will describe that and make the color, for example, blue, for example, and put the title for it, PLT dot title will be funding distribution and billion. Uh, X label will be funding in in billions. Y label will be frequency in PLT dot show. Let's see what happens in here. See, this is called 𝗗𝗃. This line, which is giving you understanding, and let's make it. Let's put it blue. So this is the funding. Funding is started from zero. Yeah. This is the bins. Here we didn't define the bins here. See in this histogram plot. It is a standard histogram plot. In this histogram plot, what we have done, we define the bins. We said, okay, we want the data to be distributed in 30 bins. So it means we divided the data, all the data points, into 30 bins. Bins from which category to which category, because we want to understand properly where the bins will be, mm, which type of categories or specific bins or should be there. So this is one of the things that you have to understand. For example, you can do bins to 30 to 40. Larger bins, it means you can understand the very deep analytics of within the histogram, how it is distributed, uh, the the data for under each bin. So this is how it says. One more thing here we have used. This is called 𝗗𝗃. What is 𝗗𝗃? 𝗗𝗃 is called kernel density estimate. Kernel density estimate, what does it mean? It is a type of plot or is a method which visualizes the distribution of data, observation points or data points in a data set. It is type of, for example, see, it means lower data are here, it goes up. It means majority of data points are here. So under this, so the density of the whole data is in this curve. Then it became lower, 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 and then in this way. So this density is a type of number of companies or observations within the specific bins. This is why sometimes you need this type of lines within this. Some people then, why it's required, some people then they are changing with the color of such density lines, and they are changing the color of it, and then because they want to calculate the area under this. So within the statistics you will understand why kernel density estimate is very much important, because you have to understand the majority of data points locating in which area. So that area is playing a key role, and you have to understand that. So this was the valuation in funding analysis. Yeah, we have done. So let's do another analysis. We have another column which is also playing a key role in our understanding. That's called, for example, industry. Yeah. So let's uh, industry analytics. Yeah. Let's do that. So for that industry analytics, what we want to do. First of all, let's industry analytics will be equal to companies and value count. Yeah. So first of all, we have to do the value count of this industry columns. Then after that, uh, let's use Seaborn and use a bar plot. Bar plot of what? That Y will be the industry analytics, industry analytics. Only index of it, okay? I will show you already why index was there. And X will be the industry analytics values of it, yeah? And let's the color put be, just ignore the color, see what it will generate. Title will be industry distribution. No, title will be PLT dot title will be number of unicorns by industry. PLT dot X label will be number of unicorns, and Y label will be, yeah. So yes. Now look at this. Why I used index and values here. So we put value count for this industry analytics, yeah? Just see what's industry analytics. This is industry analytics. See? These are all the index, yeah? So these are the index and these are the values. So this is the index and this is the value. I said, put all the index into Y. Look, Y is equal to industry analytics dot indexes should be in Y, and the values, which are this count of them, put all of them into X row. So this is how we put we used index and values there in order to put it properly. So you can make it vice versa as well. For example, Y should be here, then the values will be here, and industries will be here. But from visualization point of view, all the time, whenever you are doing categorical calculation. So for the categorical calculation, you are using bar plots instead of column plots. So you're using bar plots, and it should be managed in this way. So see, these are the companies, the industries, number of unicorns by each industry. What is now saying? FinTech, which is the industry of finance and tech, yeah? In this industry, more than 175 companies are registered. See? Artificial intelligence has the lowest number of companies which has registrations there. Why? Because this is the data set from year 2021. So 2021 was the beginning of the artificial intelligence. This is how you will understanding this um, of different industries that you're having. One more thing in this data set that we want to understand. This is the um, geographic analysis. Yeah. Why this is important? Because we have city and we have region. Yeah. And you want to know, for example, similar thing. You want to use by continent, yeah? Companies by continent, companies by countries, for example, we can use. Let's use companies, for example, by continent, yeah? So continent counts, the same thing, yeah? So we will be having the company's continent, which is this column, the value counts for that, and then we will be using the similar SNS bar plot. The continent count, the index will be on the X side, and it will be on Y side, and the values will be on the X side. This will be the title, number of unicorns by continent. And this will be the X label will be the number of unicorns, Y label will be the continent name, and then we will be having a table, a bar plot again, saying that majority of companies, more than around 500 companies, have been registered in North America continent. They're calling it North America. Then Asia, then Europe, then South America, then Oceania, then Africa. So they deal with North America and South America, different continents. However, we all understand them as one continent, but this is how the data existing in our continent analysis. This is how you can understand, for example, the number of continents. And you can do something else, for example, uh, um, uh, country region. Yeah, so we have another column, country region. So see which country has the highest number of companies uh, mm, registered. So let's do country count. So companies data set, use the country region column here, this name, country region, then value count, and then we will just select top 10 of them. Why not top 10 of them? Just assume that not top 10 of them. Why country count index, set country value, similar thing, PLT dot top 10 countries with the most unicorns, the number of companies, then Y label we have to put, and we have to plot show. So if you don't put it top 10 of them, what will happen? See, there are lots of companies here, see? So it was very difficult to understand all of them. So just say that we are just visualizing top 10 of them. These are top 10 companies, see? If you just put head 10 here, and then you will visualize top 10. The first country with the major companies is United States, then China, then India, United Kingdom, Germany, France, Israel, Canada, Brazil, Singapore. These are the number of unicorns companies based on countries and regions, which has been established. See, this is another thing that you can just put top 10 um, or lowest 10. So you can, if you just change this to tail instead of head, you can just have that one. This is how you will be having some geographic analysis in this visualizations. Yeah. So one more thing that we can have in this is we have a year founded. Yeah. So let's do some time analysis. Yeah. So time, they are not calling it time analysis. They are calling it temporal analysis or temporal analysis. What is temporal analysis? Temporal analysis, whenever you are just comparing a time in a trend. So this is trend. Uh, um, uh, for example, we have SNS hist plot, yeah. We have, for example, companies. Year founded, yeah. We want to have hereditary color blue. Okay, year founded distribution, yeah. Number of companies in this frequency. For example, we can say number of companies in PLT show. Let's see what is this. See, this is the number which is not good. Year founded. See why it is not good? Because we didn't change the year founded column to date and time. See, it is now assuming that this is number. If you're having numbers, then it assumes this column. If you have bins 30, it assumes that it can be mm, float numbers as well, which is not the case, because in specific numbers you cannot have floats. But still, floats means that if you're assuming it from another point of view, yeah, so from 6 months point of view, so you can assume that way as well. But still, for example, this is one of the things that uh, you have to be aware whenever you are doing um, um, some calculations. Coming to the lots of companies established in 2015. If you remember, last time we did the same thing, yeah. We did a year founded group by, yeah, and we came to that conclusion that companies year founded, it was just 155 companies established in one year, and this is how it has been established in that year founded. This is number of companies which has been established. Now, coming to one more thing, I just want to check something here. Companies.info. I didn't know. Is it done or not? This date joins. Date joins is already converted to date time. Okay, that's good. Now, let's assume that now we have year founded, yeah, where the companies have been founded in which years. Now let's decide if we have SNS is plot of what? Of companies date joined, color not blue but orange. Date joined the distribution. Year joined, we can just say date joined distribution. That doesn't make sense. Year joined. This is date joined, number of companies, and PLT show. Let's do that. This is the distribution of companies who joined the unicorn status and number of them. In 2000, you see, lots of companies have been established in 2015, yeah? Majority of them. But here we see between 2021 and between 2022, majority of companies have been turned into what? Into unicorn. So this time, lots of companies made huge money. And why? Who can tell me why?
Sir, are you asking why a lot of companies joined between 2021 to 2022?
Yeah, I already asked.
Yeah, okay. So, on my point of view, sir, it's because of the effects of the pandemic. So basically, majority of the stocks or like um loans are offered at a lower interest rates. So people were investing left and right. So aside from that, it is also considered that the economy has been recovering. So those factors may have played in many companies starting and founding their own businesses because of the value, the
This is not.
valuation.
Yeah, this is not the.
Uh, s- so I think most of the companies joined recently is internet and companies related to IT. So maybe so it may be due to the interest of companies on IT and AI?
Yeah. So let me. Yeah, you both are right. Both are right. But let's generate wisdom from all this information. You know why that's much important. Majority of companies, they become unicorn status. They got unicorn status. It means that their valuation exceeded $1 billion. When the pandemic was there, you know. So that's a good point. And which type of companies actually they were? They were companies, fintech, e-commerce, uh, internet services, softwares in services. So such type of companies, they made what? They made artificial intelligence. They made a huge. They become unicorn. They got the status of unicorn within the era of pandemic and after that. Why? Because whenever the pandemic was happening, lots of services become online. For example, yeah. So in online jobs, online even telemedicine, online education, online financial transaction. So uh, online e-commerce. So right now, for example, in UK, no one is going to the shops. For example, everyone is just ordering online. So this online business, whatever related to online, which is fintech, which is internet softwares, which is artificial intelligence, whatever those online services, they made a boom in their profits, and then they joined the unicorn status. So both of you, you're absolutely right, but this is how you can generate the insights. Yeah. So how the pandemic actually made lots of people uh, rich. Yeah. So this is one of the insights. Yeah. And maybe pandemic also made lots of people poor as well. Lots of these companies who are relying and specifically on physical existence of the employees. Yeah. So during the pandemic, it was not allowed to go, and then this is how those companies made a loss, and these ones from online services, they made a huge profit and they become unicorn. Unicorn means they made a profit. Their value has been exceeded 1 billion and more than 1 billion. So both of you are on the same page. Um, this is how data analytics is important. Yeah. So now coming to the investor side. So if we have investors, so another column that we have. So we analyze the country, we analyze the industry, we analyze date, region, valuation. We analyze the only thing which remains, that's investor. Yeah. So now let's investor side. For the investor side, what is the problem with investor? We have 3-4 companies within one column. But this is the problem. See, you have, for example, Paradigm, then we have this, that all of them are separated by comma. So we need specific investors, one of them. So how to do that? Let's do the companies. Then we have the select columns, select investors column. Then we have to do drop now of what? All unknown or missing values there. Then after that, string split method. What does it mean, string straight method? It means that split this one row by comma. So put all of them separate. Split this one row by comma. So whenever there is comma, put another row for it. If there is comma, another row for it. You got the point how it will work? And then make some of them, yeah? Now let's do the investors count. So whatever is the let's use another method, another function called a counter instead of value counts, yeah. And most common one, 10 of them. See, it works or not? Oh, counter is not defined. Okay, so you have to import the counter first of all, I think. This is a totally different different library. We didn't import counter at the beginning. So here from collections, import counter. This is a library which counts all these values, get the highest number of it. And instead of using value counts, can just use this function here. I hope now it will work. Because investor is not defined. But now we have investors count here. So most common them are there. So let's see what is investors count here. This is investors count. See, I sell this is investor 51 times. It happened in this select investor column. You know how it counted that? Why you cannot use value counts here? So I will show you why you can use value count here. Companies dot. Let's use this. Look at this. These are all group of investors, yeah? And if you call the value column, value count column, it just calculate that of them. So this combination, a specific combination, come 2 times. But how to, which is not what we want. We want that each specific investor should be separated by comma, which is comma, this type of comma. Then we should count in the whole column how many times that specific investor mentioned. So this investor count is a type of list which gives us the investor name and its count in that column. Investor name, its count. Investor name, its count. Investor name, its count. So see, and also it is only 10, most common 10 of them, yeah? So top 10 investors we are using. You can just remove 20 and all do that. Now, I want to visualize this. How to visualize this? This is a list. How to make now the list into a data frame. So make this investors count in a way that it should be zipped. For example, investor name should be separate and investor frequency should be separate, and we can zip all these rows into a data frame type in an array type. So how to do that? So we will be having, for example, investor's name, and one thing more, we will be having investors frequencies, yeah, frequencies. How? We will be using function zip. zip function is one of the very interesting functions. You will use that, and then you will see what will happen with this function zip. Now we have zipped this list into a data frame with the name of investor's name. So this first is investor name, and this second is investor frequency. So now we have that thing right now. Now let's visualize this. SNS dot bar plot, for example, X will be list of what? List of investors frequency, yeah? Investors frequencies. Then Y will be the list of investors name, yeah? Orientation. Oh, let it be. So top 10 investors, count of investors, investors. Let's run this. We will see what else. What happens. See, this is the count of investors. This is top 10 investors. These are investors, and these are top 10 investors from all those counts. SoftBank Group, only 26 number of investors they have made. The highest investor in these companies is 𝗗𝗃𝘃𝗃𝗃. I really don't know how it pronounced. 𝗗𝗃𝘃𝗃𝗃𝗃, 𝗗𝗃𝘃, what is this? Insight Partners, they are the same. See, Tiger Global Money. These are all investors within these unicorn companies. Look, this company invested in more than 50 companies, which become unicorn at the end. You got the point. So this is how you will find that. Now, yesterday we learned about some palettes, yeah, color palettes from SNS, if you remember. Am I right? Now let's use one of them, for example. Use, for example, this color palette for this. You will see how it looks like. See, this is the top one. This is the highest one coming to the lowest number. See, this is how sometimes whenever you are visualizing what, you're visualizing from the lowest to the highest. See, data range. This is actually data range. See, we are visualizing a data range, highest to lowest. Then you can use different types of color. You cannot use qualitative color maps, but you have to use quantitative color maps. See, such type of palettes coming from such type of palettes. See, continuous color palettes. This is how you will apply this color palette in this. Now you have top 10 investors. One more thing here I want to touch, that's called feature engineering. So I will use that. So this is which step actually. This is different types of. This is step 6. It was visualized exploration. Yeah. So this is step 6. Now coming to step 7. In step 7, sometimes you have to do some feature engineering. What is called feature engineering? The name is very interesting, but yesterday we did it. So there's nothing, just I want you that you will be familiar with the name, all those things. Look, yesterday we did the feature engineering. This is the feature engineering. Creating a new column based on the existing ones. We created a new column called years to join. Yeah. Yesterday we did. Or just, we can call it time years to join the unicorn, yeah, to join the unicorn club. So what we have done, we say that, okay, this is the company, this is the founded year. So year was founded, for example, 2021. Or company has become, for example, part of unicorn on this time, yeah. So if you just extract the founded year from the date joined, then you will have a new column which is called years to join. What it will show you how much time a company actually is in the unicorn status. So this is how you will understand the understanding of this new column. For example, years to join. Let's do that. The feature engineering. Okay, let's first examine companies that this column is established or not. Years to join. This is years to join. See, yesterday we also did some other things. For example, month joined. Yeah, so we also, that's part of feature engineering. So it means this company is now in unicorn status for 1 year, and this is for 5 years. Look, established in 2010 and become the unicorn in 2015. Now it's around 5 years, which this company is in the unicorn status. Why we use this DT year? Because from this date joined, which is the full date, it is month and date and year. We want to extract the date part of it. Only 2020, 21, 25, 2015, 2019. Then from that, extract the year founded, which is already in a year format. This is how it's called feature engineering. So this is very simple thing. And establishing new types of analytics from this data. That's called feature engineering. Now let's use a histogram, for example, to understand companies which years to join. So let the beans, however it has. And now let's use another column. Title will be years to join distribution, years to join, and number of companies, and PLT dot. Look, this is now distribution of companies. These are number of companies. This is the title, and this is the CADI. If you want to make it true or make it false, that's your thing, your top thing. You just you can just remove the CADI. Without any problem. Let's use this without CADI. So this is the distribution of companies. So this is the 0. This is the date of time. Look at this number. What this number tells us?
So there, so that number is like minus the date you have selected in your data.
So what does it say?
It's outlier, like it's minus. For example, you have selected from 2017, so it's before 2017, maybe. Is it minus?
Look, we put this one, yeah. So from this year, they joined the unicorn, and this year founded, yeah. We said, okay, now this is the year which the company joined the unicorn club, and this is the year which the company has been founded. do you think that the company will be founded in a way that it should be already have the status of unicorn? Do you think is it possible? It means, do you think that if company is a unicorn 5 years ago and then founded today, is it possible?
So it's impossible. When
Exactly.
the company is not there, so how it could be unicorn?
Exactly. This is called data validation, yeah? So whenever you are coming to such type of points, it means that, okay, an year founded and date joined. There are one data point, which is year founded is lower than date joined. And that should be removed from this data set, you know? And this is how you will find it whenever you're coming next week. Some more visualizations. We also have we can go deep into the feature engineering, but in the visualization part, for example, I can add some more visuals for you that, for example, you will understand and see how we can play more with the visuals. For example, if we call box plot visual that we didn't use, data will be the company's data, that data set we have. X will be the funding, and Y will be the industry. So we can define a palette as well, and it will be the funding distribution by industry, and funding will be in $1 billion, and it will be industry, and plt.show will be, and we will see what else we can do there. This is a box plot. See, this is a box plot of what? Funding distribution by industry. So all of them, they are showing a box plot here, and this is very important. So just make a palette of, for example, set 3. Now, don't tell me that you don't know what set 3. Set 3 is already there, yeah. So an SNS palettes. So then just choose a palette here. In fintech, for example, look at the fintech, for example. The minimum value in fintech industry is 0. The maximum value is around 1 billion. Yeah. So funding at when the company was founded. Yeah. At the beginning. There are some outliers which existing in this country. These are showing the values which are larger than the maximum number. This is the maximum, but this is the range. Yeah. So this is the IQR. So it's larger than that, but it assumed that it's not an outlier because we already removed the outliers. Yeah. We said 1.5 of IQR. Larger than that is outlier. Less than that is also an outlier. So now we have nothing less. Larger than that, everything is removed. But now it is now formalized. So this is how the box plot looks like. So you can have each specific industry, the minimum value of funding in that industry, the maximum value of funding in that industry, the mean value within that industry. So that's very important. Look at the mean value. Now analyze the mean value. Look, this is the lowest mean value. Am I right? What does this means? And this is the highest mean value, automation and transportation. And this is the lowest, artificial intelligence. So what does it mean?
So in the auto and transportation, the number of companies who has invested, or maybe they have invested like more money. So
Uh,
because of their lots, because of their investor, because of their invest, so they have got high value of high mean value.
yeah, it means in a very simple. You're right. You're absolutely right. It means that in automation in transportation industry, companies that they want to establish their own companies. If you want to make some investments and make a company, found a company, yeah. So this mean value is larger than all of them. It means if you want to establish a company in automation and transportation sector, you need large amount of monies to establish and fund your company. It's around it's in billions. It's around point 7978 billion dollars you need to establish such a company. And the lowest uh, amount of money that you need to establish a company, it's in artificial intelligence. There's nothing you need to establish there. See, the mean values of those companies are on this level. So it means you need lower number of lower amount of money to establish a company in artificial intelligence sector. This is how it works. You got the point. So this is how boxplot gives you different values as well. So even the minimum value of automation and transportation is larger than the lots of other minimum values. So this sector, establishing companies in this sector requires much more money. And in this sector, you need less money. So this is how the mean value and distribution of boxplot is giving you understanding how to deal with, for example, by industry type. Yeah. So this is the industry type. One more thing I want to do some uh, uh, correlation analysis. Correlation analysis is very important. At the first time, I also did some, for example, let's only get the numerical columns. So we have evaluation, funding, uh, year founded. What happened to this? Mhm. One more column that we have time to unicorn. Yeah. So what it's called? It was we did a feature engineering. Yeah. Yes to giant. This is also a numeric column. Yeah. And then we will put drop now here. Drop now if any null values are there. So we will just want to drop those null values. These are numerical values because if there are null values, then correlation will not work. Now let's use correlation function. It's called numerics, this numerics data, which we defined, and that's core, which is a method. You're calling that. Then let's call a heat map. So we will be having correlation annotation true, color palette cool warm. Let's make it cool warm. One more thing we want to add here. Let's put, for example, percentages. Yeah. So we want to have percentage to F, 2 decimals. Yeah. This will be correlation matrix, and this will be the during the plot. Now we have to have a correlation matrix. This is correlation heat map. These are the columns: valuation, funding, year founded, years to join. This is valuation, years to join, year founded, funding, and valuation. So these are the relationships. This is cool warm. This is the color palette. CMAP. This is the color palette. So blue, This is the neutral palette. See, this is 0 is the neutral, as we mentioned here. See, in data visualizations, this is how you will work. Coming from this to this, and this will be the neutral coloring. This is the neutral coloring. The highest is the red, the lowest is the blue. So year founded and years to join, they don't have any correlations. They have correlations, but it's very negative correlation. Minus point. So this is minus correlation, this is plus correlation. Yeah. So valuation and valuation, sure, they have 100% correlation. These are percentages, okay? And these percentages, it means one, it means 100% correlation is there. Correlations are there, but these are the heat map shows the percentage of correlations, and positive correlations and negative. So between valuation and between funding, there is around positive correlation of 52%. See, this is how. Between year founded, between years to join, there is totally negative correlation. So if years founded increasing, years to join decreasing. So this is how this correlation exists. These are actually neutral correlated factors. This is how you can also understand the correlations of examining different things. One more thing, we have time? Yeah, we have one more time. We can do that. Year founded, yeah? Year founded count. It will be the companies, column year founded, value counts, and for the value counts, do you think we should do the, let's instead of the set index, use the sort index. Sort index. Now, let's plot it. PLT plot. Plot what? Year founded count. This year founded count dot index. So just get the index of it. Year founded count dot value of it. Put the marker O, color, blue, name. It will be year founded distribution or number of companies, not distribution, but this is plot. Number of companies by year. Year founded, just you can just call it year. And number of companies in PLT show. See what happens. See, this is just a simple plot of saying that in which year, 2005, 2007, 2010, and 2015, the same thing. Then this decrease. This is a type of line type. However, we cannot use it appropriately for this this function, but still, because we have a timeline here, and we have number of companies there, we can use this line chart because line chart also shows the trend. But this also gives us a trend. Trend was like this, look, from 2011 to 2000, almost 17. This was the peak of establishing companies. Then it decreased again. See, this is how you can gain an insight from this data. We can do one more thing, for example. Oh yeah. Let's do something else. Top 10 valuation, yeah, companies. How to find that? There is a very interesting function. It's called N largest. N largest, it gives you the largest number of a specific column. So for example, I want top 10 valuation. Yeah, I want companies, my data frame, n largest, 10 largest numbers of which column? Of the valuation column. Then what else I want there? I want from that data set the company and the valuation. So I need two more columns there as well. I need company column and I need the valuation column as well. So these both columns should also existing in this data frame. Now I want what? If I have this data set, I just did a subset of my data set. I filtered the data set. Now let's use bar plot to plot it. What will be my data? Data will be top 10 valuation, this one, which I recently created. Top 10. This will be my data. What will be the X? X will be the valuation. What will be the Y? Y will be the company. Then the palette, you can choose whatever palette you want, but this time I want another palette. So what, for example, spectral palette. Top 10 companies by valuation. Valuation is in $billion, Y label, and PLT show. Let's see. So top 10 companies by valuation. So all these top 10 are having the valuation, for example, of 6 billion. So if you just put the top 20, maybe it will change somehow. But all of them, lots of them are on 6 billions. So this is the top 10, top 20 is also 6 billions. If we see just top 50. This is now it changed. So this is the huge number of companies. All of them are in 6 billions. These are the top valuations. All of them are in 5 billions. This is how. So we just, if you just put the number 50, but this is how lots of companies are in this specific values. For example, here, see, this is the lots of them are on 6 billion. So same companies, they invested in 6 billions. Why it became in 6 billions? Because we removed the outliers, if you remember. Yeah. So if you remove the outliers, so lots of companies which are specific at 6 billion, they will remain at 6 billion. So it will be there. Now you can change this, or you can just ignore this one. But if you just put it top 10 as it was, so it will give us the understanding that these are the top 10 companies who invested, who are all of them, their values are 6 billion. These are the name of those companies. See, Black Unicorn Factory, Web Doctor, and all those things. And this is the feature engineering. I think this is how you can conduct an EDA. This is the end of conducting an EDA in 7 steps. Each step in detailed analyzed, and I think it's even more than the EDA. We already covered lots of visuals. We covered the different points of visualizations, bar plots, charts, distribution plots. Different of these steps have been covered, and we analyzed different subjects in this data sets. We did feature engineering. We understand how to handle the missing values in our data set. We did industry analytics, geographic analytics. We did time series analytics, temporal analysis that they're calling it. We did some investor analytics. We did some descriptive analytics. We cleaned the data. We handled the missing value, and we properly understand the data set. This is how proper data set can be imported can be analyzed, and different visualizations extracted from it. And then based on that, you can just extract different insights as well. So I think this is it for today on exploratory data analytics. I will be coming back to the questions. Okay, Ilyas Mohammadi, please.
Thank you, sir, for your nice presentation. I was just asking that how we can plot top second largest companies. If you get what I am asking.
No, I didn't get what you're asking.
I just want to plot the second second top 10.
What do you mean by second top 10?
For example, if we have 20 companies, the first top 10 is 1 from 10, and the second is from the 11 to 20. So the second top 10 is from 11 to 20. How we can plot this?
No, that's very easy. But the point is, do you think it sounds mathematically sound that I want to plot second top 10? Do you think
As
mathematically it sounds?
I think as if some cases it requires how we can do that.
Okay.
Just,
yeah, that's a question. Yeah, we will come to that. Thank you.
Thank you.
Ashley?
Yeah, sir, I just wanted to ask, how are we going to tackle more about the data visualization? I wanted to know how we can add legends within the bar, for example, a bar plot. If we're doing a bar plot, in the industry analytics, we had, companies like fintech, internet software and services. But I wanted to show the value for under fintech, like for example, 187 within the bar plot. Are we going to tackle that part of data visualization?
Yeah, but you see that today was not sufficient time. Yeah, I mean, so this is yeah. So if you
Yeah,
let
it's
us, we
okay.
will continue. Yeah.
Okay, thank you, sir. Thank you
Yeah.
so much.
You're welcome. To Takhil, Abdul Rauf.
Hello, sir. Hope feeling well and great. Sir, I have one question. If you can share the slides of globe and also the practice you are doing in the globe, that will be better for us to learn more and review your slides and your coding style.
Oh, okay, I will share that. Did you write any codes today?
Yeah, I read it, but do you know when you write the code, I just